I don't know anything. I'll steer you wrong.
So should we do the opposite of what you say?
Yeah, if you go broke, don't blame me. Disclaimer. All right, everyone. May the 4th be with all of you. And today is May 4th. All right, so this is day 2 of the final review. This is continuing off, so here we go. This is where we left off yesterday, right?
Yeah, it was.
We did that one. Okay. All right, determine the exact values of each expression. So for these, you can really just type these in probably. Make sure you're in what mode? What mode should we be in for these, looking at the examples? Yeah, radians. I'm in radians. But you can use your unit circle. That would probably be better. But you can just type these in. And all you got to do, just like you in the past, you always work from the inside out. So we're going to do the arctan of 1 first. The arctan of 1, I don't know what that box is for. The arctan of 1, if you look at your unit circle, is pi over 4. So that's the first occurrence. And then once you do the arctan of 1 is pi over 4, we now are going to look at the unit circle again, or you can just type this in, cosine of pi over 4. So this wants to know when what's the x value at the angle pi over 4. So you look at your unit circle and you either type it in or you look at it on the unit circle, and you should get rad 2 over 2. Pretty simple. You might be able to even type this all in at once as long as you don't mess up your parentheses. So that's probably really important. But I think to be safe, I would probably maybe do one at a time. Some calculators have a hard time for whatever reason of doing multiple in the same line. I don't know why. I've come across that. You might get an error or might give you a wrong answer somehow. But inside out, same thing with this one over here. You look at your unit circle, sine of pi over 3. It wants to know what's the y value at the angle pi over 3. So you look at your unit circle or you type it in, and you should get rad 3 over 2. All right. Next, we look at, this is the arc cosine of rad 3 over 2. So this wants to know what is the angle when the x value is rad 3 over 2. So you can either type this in or you can just pull it from a unit circle. I think either way worked just fine. But the angle is pi over 6. So the x value, the angle when the x value is rad 3 over 2 is pi over 6. Fun stuff, right? All right. Any questions? Any questions?
None.
None.
Besides, thank you for not making me work this out.
All right. So what is the period of the function f of x equals 2 cosine of pi x over 3? So you get to know, I guess you know the different parts of your function, your trig functions. So, we all know that that's the amplitude, right? The coefficient is the amplitude. And then the period you're going to have, for sine, cosine, tangent, and then the other three trig functions, you have a formula for period. Any of you recall what that formula is for cosine?
Which formula?
The formula for period. 2 pi over k. That sounds right, Emily. Yeah, I think that sounds right. Yeah. Yeah. So over here, I pulled it out from this lesson here. So sine, cosine, and cosecant, secant. The formula is period is equal to 2 pi over k. For tangent and cotangent, I'm pointing to it, but I don't actually have my pointer tool selected. Sorry. For tangent and cotangent, the formula is p equals pi over k. P equals pi over k. So, on your final, make sure you are aware that tangent and cotangent have a different formula. That is a good way to miss this problem, is if you just assume it's 2 pi over k, which it might be. I don't know. Oh, and then, yeah. So your k value is what's in front of your x. So remember, it's amplitude times your trig, k times x, and then plus your, what is it? What variable is that? Is that, I think, plus c? Drawing a blank here. I think it's plus c. So we just plug that stuff in, 2 pi over 3. You can probably just type this in as you see it. Don't forget, it's 2 pi divided by parentheses around pi over 3. That's important. If you do 2 pi divided by 3, it's probably going to be wrong, most likely. So remember, it's 2 pi divided by this fraction. So pi over 3 must be in parentheses if you type it in. But I like doing things by hand. I personally wouldn't type this in. I would just work it out. I think it's good for the brain. So we do 2 pi multiplied by the reciprocal, so 3 over pi. The pi, this pi and this pi cancel out. And then you have 2 times 3 on top, which gives you 6. So the period is 6.
So I don't know if I'm sure it's not the same for all problems, but with this problem, you can just type it in
Try
like 2 pi over 3 and still get 6. I tried it. Yeah, you still
of
get
course.
6.
As long as you type it in right.
Well, yeah, but I didn't put the pi over 3 in parentheses. I mean,
For your calculator, it worked out, but not all of them will.
yeah. Yeah, I'm sure the Apple calculator is probably gonna screw it up.
Yep, I would guess so. All right, real world applications of trig functions. All right, these are fun. I like these word problems for trig. We can apply it. I think they're fun. All right, so the function f of x equals negative 10 sine of pi x over 4 plus pi over 2 plus 8 models the temperature of a room during an experiment in degrees Celsius. Get my pointer out. X hours after the experiment begins. How does the room temperature vary during the experiment? So this is important. X is in hours. You probably want to underline that. That's important. All right. When the experiment begins, the temperature of the room is blank Celsius. All right. So X is hours after the experiment begins. So if I want to find the temperature when the experiment begins, what should I plug in to my formula here? One, two. I like how 3 of you are tabbed out and not paying attention. Sarah, George, Julia, I see you. Yep, you plug in 0. You plug 0 into X and you type that stuff in. And what do we get when you type in 0 for X? Go ahead and try it. Make sure you're in radians, of course, because we're talking about pi over 2 is in radians. So you plug in 0, Antonio, and you got -10.
Yes.
I didn't. Anybody else?
Just to, well, never mind. If I do that, you can give everybody else the answer.
Make sure you're in radians.
Okay.
Oh, and Antonio, I think what you forgot this plus pi over 2. Well, you probably forgot a lot. Oh, you forgot +8.
Yes, I did. You're right. Yes.
That's what you forgot.
That's what. Yes. Okay. So it's going to be -2.
Okay, I agree with you on that one. Yes, I agree. Yeah. So on these problems, you really want to, when you work out these, don't just look at the original equation on your paper when you're going through your test. And this goes for this class or whatever next math class you plan on taking, whether it's high school or college. You need to rewrite the equation by itself so you can look at it. And once you write it, compare what you wrote with what is said in the problem. So you don't, make it's really easy to miss that +8 because it's kind of shoved in that word problem. A lot of you realize after you submit a quiz or a test that a lot of the things that you make, either you don't know how to do any of it and you totally guessed, or you just made something so simple, and if you would have showed a little bit more work, you would have got it right. I'm here to remind you of your mistakes and your shortcomings in math so you don't do it again. What was what, Emily? No, math just got dark. All right. Next part of this problem says, after blank hours, the room reaches its high temperature of blank Celsius for the first time during the experiment. So there's two ways that I can think of right now to approach this part of the problem. One being easy, and one being a little longer and more math, I think. So the easy way, any ideas? What is the easy way, you think, to approach this second part of the problem?
Well, first, what do we need to know how many hours? Because it doesn't tell us up here.
Not necessarily. But you can think of like an easy way to figure out what the max temperature is going to be in this trig function. Good job, Emily. Graph it. Yes.
Okay.
Yes. Remember, trig functions like sine, cosine, or except tangent. Sine, cosine, it's a wave, right? It goes up and down, up and down. So the temperature of the room, because it's a trig function, this is a sine function? Yeah, it's a sine function. You know it's going to go up and down, up and down. So if you graph it, remember, when x is 0, that's when you start. And if you can just trace the wave, and this problem should be, I think, easy enough, where if you graph it, you'll be able to determine what x is going to be at your first maximum, your first peak. So hopefully all of you, as I'm saying all this, you're in Desmos or GeoGebra. I like Desmos personally. That you're typing this in and you're trying to identify the max. So I'm going to wait. So remember, guys, I have 25 questions to get through, and I have all week. So I don't have to go very fast on this review. Now, on the last day of the review, if we have a lot left, then I will go fast. All right. So it looks like we got Michaela and Haley. They're tabbed into Neuro, which means they're not graphing it in Desmos or GeoGebra. Hmm.
Do we hold them to our answers or just tell you?
Let's wait another like 30 seconds before we start typing answers in.
Okay.
I want people to get a chance to type it in and see the graph. All right. So let's do this. Let's do the first blank. So after blank hours. So what does X equal? What else you get? What you find on the graph? 4. So you're Antonio saying after 4 hours we're going to have the max temp. Anybody else agree with that? Anybody else agree? Kayla says yes. Remember, Antonio's wrong quite a bit.
Also, how I improve, they'll become not scared to fail.
Ooh, I like that. Not afraid to fail. My man. It's a good motto. Don't be afraid to fail. It's okay.
I'd rather fail here than fail in the tests.
It's what you do after you fail that makes up for it. Crying's okay. It releases endorphins and you feel better for a little bit. Crying is healthy, just FYI. All right, Antonio's correct. Yes, it is. So you can see on Desmos or GeoGebra that when X is 4, that's when we have the peak. And what is that peak? Everyone in chat, what did you get? Remember, this blank is in Celsius.
I converted for fun.
You know, if Americans only use Celsius and like meters, centimeters, I think it'd be a better place. So it is 18 Celsius. So if you guys are going into like the science, engineering field, requires a lot of math, physics, you're going to be annoyed by the fact that you have to think in metric system, and our brains are wired for, well, system we use now. I think they call it the SI units. Imperial, I think it's called also. All right, now the last part of the problem says 2 hours after reaching its high temperature for the first time, the temperature of the room is blank Celsius. So there's 2 ways I can think of doing this problem. So once you know the peak, which is 4, what do I have to plug into my equation to get my temp? 6. Yeah. So first way I can think of doing is you plug in X is 6 into your equation, you know, a little typing, and then you hit enter, you get your answer. Or you can go into Desmos or GeoGebra, go when X equals 6, and then click and see what your Y value equals. So Antonio says it equals 8 Celsius. Anyone else agree with him?
Why would we do 6? Like, I'm confused, like, how.
All right. Could you read the sentence starting right here for me out loud? On mic.
I see. Okay, yeah.
Oh, you have to read it.
Just,
No, read it for me, please.
no, No, let me fail in peace, please.
No, fine. Antonio, you read it for me.
2 hours after reaching its high temperature for the first time, the temperature in the room is blank Celsius.
Yes, yes. So 2 hours after reaching its high. So remember this at 4 hours is when it reaches its high. So 2 hours after that high temp. So 4 plus 2 gives us of 6. And I think you said it was 8 degrees. Is that right?
Yes.
Yep.
There
8
you go.
degrees. All right. All right. All right. Any questions before we move on?
None.
All right, the graph of a cosine function has an amplitude of 4, a vertical shift of -2, and a period of 6. We want to graph the function.
You want me to keep reading it for you?
Did I not finish it?
No, your mic went off.
What did I stop at?
You stopped at the graph of the cosine function. You didn't say anything about the amplitude or anything.
I thought I read that. Sorry. Antonio, yeah, go ahead and read it for us.
The graph of the cosine function has an amplitude of 4, a vertical shift of -2, and a period of 6. Graph the function. My brain is too advanced and almost gave away one part of the answer.
All right, so you can go into Desmos or GeoGebra and just kind of plug this stuff in to play with it, or but given this stuff, we can graph it. So a cosine function. Let me get my pen out here. Hang on. No, I should be on my Mac for this. Neuro and Windows don't like touchscreens. So a cosine function, I believe, starts at y value is 1, right?
Yes, the y-intercept is 1, x is 0 at that point. So it's 0, 1 is the ordered pair.
Yep. All right, and then
it hits 0 at pi over 2.
Yep.
It hits x, I mean.
So this one talks about the period of being 6. So let's do the vertical shift first. So the vertical shift is 4. So that means, I'm sorry, -2. So that means we're going down 2 units from that point. Let's see. What's the amplitude? Oh, 4. So the midline is at the origin for the parent function. So you want to look at that when doing your shift. So because we're going down 2, I'm shifting my midline down 2. So let me move this 1, 2. So everyone agree that my new midline of this function is at -2. That sound right? Okay.
It does.
Now, once you shift your midline, we are going to work on the amplitude. So the amplitude is 4. We don't have a horizontal shift, so that makes this really easy. So amplitude of 4. So that, remember, the amplitude is from the midline to a peak, whether it's going to be a max or a min. So the parent function amplitude is 1 by default. So we would go up 1, but because it's 4, we go up or down 4 units. So from our midline, we're going to go up 4, and that'll be our first point. So I'll just move this point here. 1, 2, oh, actually, it was, right. Actually, I'll just delete it.
Would you mind if I put a circle up there? Because it's kind of...
I'm going to do it again.
Obviously.
Hold on. 1, 2, 3, 4. Okay. All right. Looks good?
Much better, yes.
All right. So there is the starting point of this cosine function. So remember, parent function of cosine start high, and then they do their descent going down, and then back up again, then down again. So that's why I'm only going to graph this first point. Now, it then says the period is 6. Now, what does the period tell us in a trig function?
Can I
Go
say
ahead.
that, Mike? Oh, okay.
Let's give a chance in chat, ones that are paying attention. So, students, paying attention, what does the period do for a trig function? What does it tell us?
I thought I was purposely not answering.
You're not, Antonio. I want someone else to answer. Michaela, you do know this. You do know this. Now, if I tell you the answer, you're like, oh yeah, I knew that. Of course. It's there somewhere. Emily, you're tagged back in. What's going on? How wide it is? I guess. So I know what you mean, but I want different words to explain what you mean. I would say I understand what you're trying to say, but I want different words than what that is. So Emily says, the period is how wide it is, and I guess that's sort of correct. Anybody else have more specific words? So Michaela says it's the length of the whole up or down. So that's also technically correct, but I want more specific wording. Emily, there you go. Perfect. How long it takes for it to repeat. So the period is 1 full cycle before. So 1 full cycle before it does it all over again, right? Yep, 1 revolution. There you go. There you go. So I knew what you meant, Emily and Michaela. So you were thinking that, you just didn't have the I guess the right verbiage, but you know what it meant, so we're good. Math isn't a vocab test. So all right, so the period is 6. So I'm going to go over 6 units to the right. 1, 2, 3, 4, 5, 6. I'm going to do another point here. All right, that's a beautiful point. Totally. So that's when the graph will start over. All right. Now, if I go directly in between those 2 points, I'm going to do a different color here. So I'm going to put a point here. So I did a different color. I did it on the same line to show that is where in the x direction where your graph is going to change directions from going down to back up. Now, I'm going to move that point to the midline. Okay. So remember, amplitude is from your midline to the max or to the min. So remember, half of the period is when the graph changes directions. So I have to go down another 4 units. 1, 2, 3, 4. Hopefully I counted right. 1, 2, 3, 4. All right. All right. So I'm going to put a few more points in here, just so when I actually do my graph, it looks good. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 6 again. I should probably go the other direction too. Okay, I think that's enough. All right. Now I'm going to do my awesome graph. Let's do it in red. All right. Please, Miro, don't fail me. And then doing the other side. All right. So there's our graph. Now on your final, you're going to have to use their graphing tool. Now, if you've been doing your practice modules and while doing the practice examples and graphing these, and you did your quizzes and you graphed in the quizzes, and then you did the test for this unit, which is unit 3, you should have had practice on using that graphing tool and graphing correctly. The directions are pretty specific. I think it says like graph a max or graph a min, or I don't know. It tells you to graph like 2 points or something. But when
And
you
it
do
wants the one
graph,
close to the origin. That's the hard
yeah.
part about it.
So as far as I know, it wants you to graph points to the right of your origin, or even on the origin. So like this point here and this point. It might even want you to do like your midline point, which is like this point here, right? I'm sorry, it's going to be, yeah, this is not accurate, but it's going to be somewhere over here. Anyway, it'll tell you to graph whatever points, but it wants you to stay to the right of the origin. And when you plot the points correctly at whatever it says, it's going to generate the graph for you without having to plot so many points. So, obviously graphing this by hand, I had to do a lot more to make sure it's accurate and whatnot, but that's how you would probably want to approach this problem, in my opinion. Any questions before we go on? All right. Year 3. All right, what is the equation of the cosine function whose graph is a reflection over the x-axis, has an amplitude of 10, a period of pi over 4, and vertical translation of 3 units up? Good question. Let me do this. I'll give all of you 3 minutes to mess with this and see if you can figure it out. 3 minutes. So I'm going to give you a hint. You need to find your k value. So in order to generate this equation, you need to calculate what k is equal to. Once you know what k is, it's pretty easy. And let me write something out for you. So your function, oops, that's not a map. So remember, you're going to have your amplitude. I'll just do a capital A for amplitude. And this is going to be what, a cosine function? I'm so mad at Neuro. And then you're going to have your k value, x. And we don't have a horizontal shift, so we don't have to worry about that. And then you're going to have your plus your vertical shift. And I think we called it, I think it was h, right? For trig, I think it's plus h is the variable we used. So that's the form of your equation. Yep. There are 10 seconds. Ooh, time is up. All right, in chat, anybody have the k value calculated? Emily, it's okay, Emily. Emily says the k value is 8. Anyone else agree with her? All right, now how did you calculate the k value? What formula did you use?
Um, 2 pi divided by the period, so 2 pi divided by pi over 4, because you would write out pi over 4 equals 2 pi over k, and then just flip it.
Nice, nice. So
you would have k
she
equals
is
2 pi over.
She is correct. You are using these equations. P equals 2 pi over k in this case. You know the period. You're trying to solve for k. So that's why you would use those equations. You are totally correct. And it is, k is 8. So that's the only piece you need to create this equation. And again, remember, tangent and cotangent have a different formula. So I don't remember if they want you to create like a tangent or a cotangent equation, but make sure you're careful on this problem. I hate for all of you to miss an easy problem because you just assume it's always going to be p equals 2 pi over k. So yeah, period is pi over 4. We're going to remember that little shortcut. Remember diagonals, you can trade places. So I used my little math shortcut. But you easily could have just swapped pi and k and then multiplied everything by 4. It's however you want to approach it. I went ahead and I swapped k and the entire fraction. You can do that too. So we could have done k and pi only in the swap, or I could have done k and the entire fraction. They both are the same. If you do it the way that I did it, you have to flip and multiply next. So you're going to have 2 pi times 4 over pi. The pi and pi cancel out. 4 times 2 is 8. So I'm a fan of doing stuff by hand. I don't like using the calculator unless I really have to, or like trivial stuff. But I think it's really good showing work, taking your time, having good handwriting. The more you do by hand, I think it really makes your brain smarter. And we just fill everything in, right? And the reflection. So don't forget this piece. When you are reflected over the x-axis, right? So it's flipped vertically. That's what makes your amplitude negative. So that negative is the reflection. If it says there is no reflection, it would be positive because it is a reflection over the x-axis. It's negative. Is that clear? All right. K value is 8, and then the vertical translation is 3 units up. That's why it's +3 at the very end. Every day, Emily, every day. All right, let's go. All right, general solution. These are always fun. So what are the solutions of the equation 4 sine squared of theta plus 2 sine theta equals 0 on the interval 0 to 2 pi? So this is where we need do we need trig identities for this one? No, we don't. Nope. This one's actually set up pretty nice. It's relatively simple. So we're solving for theta, right? Remember, so when you want the general solution, you're solving for theta, and then once you solve for theta, that's when you're going to add that little piece to the end of your answer. Oh, actually, mine. So this question does not. So my title, I mislabeled my title. I put general solutions to trig equations, but the directions say what are the solutions, not the general solutions. So you actually do need to create. All right. Well, I'm jumping ahead of myself. Let's actually get to that step before I start talking about it. All right. So our first goal is, well, we got to solve for theta. Let's do that. Ideas. Ideas. All right. If this was not a trig function, and I said solve for x. So this is just a regular equation. We're solving for theta, solving for x. Factor it. Yeah, there you go, George. So George is right. We want to solve by factoring. All right. So we know we got to solve by factoring. So what can I do? So we're going to factor out the common factor, which is 2 sine theta. Yep, that is one way to do it. I'm looking at my work right now on the previous page, and I mistyped it. Whoopsies. It's an easy fix, though. All right, the common factor is 2 sine. So we are going to GCF a 2 sine hold on a second. I think I mistyped the entire thing. Oh, I see what I did. Why would I do that? I guess that's how I was thinking the time I did it. Okay. Well, so you could GCF a 2 sine theta out of it, but what I did for whatever reason, I divided everything by 2 to reduce it by a factor of 2. Most people probably wouldn't think of that. I don't know why I did at the time, but our answer will be the same in the end. So I divided everything by 2 to get down to this, and then I factored out sine theta. But really, you could have just factored out 2 sine theta, and you would have 2 sine theta outside and then 2 sine theta plus 1 on the inside. So remember, when you pull out, whether you pull out a sine theta like I did or you pull out a 2 sine theta, when you pull it out, it's not 0. So when you pull out this entire factor, it's a 1 because going back, in this case, sine theta times 1 gives me back to sine theta. So when you GCF, ask yourself, if I multiplied it back in, would I get back to the same, the previous step? If the answer is no, you didn't factor it right. If the answer is yes, well, you probably factored it right. Does that make sense? So I would say that this is probably the most common mistake is when you pull out this like sine theta. A lot of people they just leave it blank and they just have a single term inside. So that's the most common mistake is they pull this out and then they, whatever reason, they just drop it completely, which you can't do mathematically because then it wouldn't multiply it back. But anyway, all right. Once you have it factored, what do we do? Set them both equal to 0 and solve. Yep. So again, people who went ahead and they just pulled out the 2 sine theta, they would have 2 sine theta right here, and then they would still have the same that I have here. And then you would just have a 2 sine theta right here. And then having that 2 out in front here, I would then divide everything by 2 to get to this step. So we're going to end up getting to the same step anyway. I just did my divide by 2 at the very, very beginning because it worked out that way. Remember, there's one way, more than one way to approach these problems. All right, so next we solve this. So yeah, we got 6 minutes. I want everyone to solve these 2 equations. Ready, go. I'll give you 3 minutes. So don't forget your final answer. You should have 4 answers for your final answer. If you only got 1 for each, it means you're not done. All right. So for sine theta equals 0, what did you all get for this one? Now, if you only got 1 of the answers, just go ahead and put that 1 answer. That's okay. I'm going to guess if you got only 0, you probably typed it in and you didn't use your unit circle, right? So remember, the interval is from 0 to 2 pi, so you got to use that full rotation to see when this is true. So the arc sine both sides. So the question is, you look at your unit circle, and the question is, all right, what are the angles when your y value equals 0? At 0 and pi, yes. Using your unit circle, you get 0 and pi. Yep. You type it in, you only get 0. It doesn't actually use the full rotation. Now, you could have, if you did type it in and you got 0 as the only answer, using general solutions, this is the part I was getting ahead of myself. When you have theta equals 0, general solutions, when you're dealing with sine, remember, you can do half rotations. So it's going to be, what is it, 0 plus pi then? No, it's not. It'd be 0 plus 2 pi. Hold on, scratch that idea. That idea doesn't actually work. Just kidding. So you have to use your unit circle to identify both answers, or you're going to miss half of them. All right. So at the angles 0 and pi, the y value equals 0. All right, that should be pretty clear if you have it in front of you. All right, next, what did you get for this answer? What 2 answers? 7 pi over 6 and 11 pi over 6? I would agree with you. I would agree with you. So you would subtract 1 both sides. You would then divide by 2. You would then arc sine both sides. So there's the steps leading up to it. And then the question is, what's the angle when the y value is -1/2? So you just look at your unit circle. You identify what angles when the y value is -1/2. And Antonio listed both of them, and they are correct. 7 pi over 6, 11 pi over 6. Now, looking at the unit circle for all 4 answers, 0 pi, 7 pi over 6, 11 pi over 6, it wants in the interval 0 to 2 pi. So the good thing is all 4 answers, they fall in a different quadrant, which means it covers the entire rotation. Now, if that didn't happen, you would have to maybe use the general solutions, but that would probably only apply if you're doing tangent and cotangent, because tangent and cotangent have general solution of whatever you get plus pi, or plus or minus pi. But for ones that are just sine, cosine, cosecant, secant, doing it this way with the unit circle is straightforward. Any questions on this one? All right, so we're going to stop here, and we'll continue this tomorrow. So may the 4th be with all of you. Have a good rest of the day, and see you tomorrow.